we can begin now. Hi, guys. Welcome to this Covalent and Flare Network AMA. Thank you guys for tuning in wherever you are. We will be going ahead with the AMA first, and if you have any questions, feel free to pop your hand up and raise your hand in the end, and I'll invite you to speak. Today, I'm very excited to invite Hugo Philin, the CEO and co-founder of Flare Network, to join us today. We'll be learning all about Flare Network. What is it? Why should you be excited as a crypto enthusiast, as a blockchain enthusiast, or as a developer? And also the grants and opportunities and how you can start building on it. Without further ado, can I invite Hugo to maybe introduce yourself and also give us a bit of background about the Flare Network.
Absolutely. So thanks for having me. My name is Hugo Philin. I am co-founder and CEO of Flare. Started with a team of three in late 2017, and essentially three co-founders. We all met at in or around UCL in London, and Flare is we describe Flare internally as being the blockchain for data. So I think there's a huge similarity between what we do and what you do. So you do data for people accessing it off-chain, essentially.
Yes.
Flare, and you aim to be essentially the most viable and most complete access point for blockchains, to third parties, and we aim to be the most complete on-chain data source. So in brief, Flare is a blockchain. That blockchain itself secures essentially the acquisition of three types of data: price data, blockchain state data, and Web2 API data. So that's a pretty broad gamut of data. And with that data, you can use smart contracts on Flare to build totally different applications that can currently be built in blockchain. And then you can build on top of the blockchain. So you can build on Flare to serve whichever ecosystem you like. Or you can build on top of Flare to build interoperability solutions. So because Flare has an ability to get data about other blockchains, it allows developers to build things like bridges and relays.
So it's like a bridge solution and Oracle solution built into the network itself.
And a layer one, yes, because existing bridges and oracles are highly centralized, expensive, and very, very hard to extend. One of the things that's really important is development is highly stifled. If a technology is really hard to extend, it means you just don't get people playing around with use cases. And really, all development in this space comes from playing around with use cases.
Yeah, and I suppose the big interoperability promise can only be satisfied when you're free to get data from other sources instead of just like borrowing on-chain data, right?
Yeah, exactly. I think you need to have as much freedom as possible.
Awesome. So you guys started this in 2017. You all saw the deficiencies in the current kind of setups where it's like a little silos, right? Every network kind of is their own silo, blocked off mainly, and sometimes connected by bridging solutions that may or may not be secure. And also without a kind of like good, I suppose, like Oracle or data feed mechanism. And you guys started developing from that central problem since 5-6 years ago.
Yeah, exactly. So, I mean, first we looked at consensus, uh, did some research in consensus, created a consensus algorithm called the Flare consensus protocol.
Mm.
But then really we got stuck into interoperability. I mean, I kind of, I don't just look at blockchains as silos. I think that's, um, I think blockchains today without strong interoperability are basically North Korea, meaning meaning that they have no interactivity with the rest of the world. But yet, if you think of the rest of the world as being highly interoperable, you can see that that's certainly more valuable than being less interoperable, as North Korea's economy is not fantastic.
For sure, for sure. Could you give us a brief idea of the mechanisms that enable this interoperability to happen on Flare? Because I read briefly that you guys have got uh, this Flare time series oracle as well
Yep,
as a state connector. I was
yep,
wondering, like, if you could give us a bit of background about what they
yep.
are.
So broadly, the Flare Time Series Oracle is an oracle, as it says, that for time series data. This means data that is um, fluctuating over time, but also, most importantly, does not come from a single source.
Mhm.
So let's say you have an API, and that's the only source of that data. That isn't something that's necessarily useful for the Flare Time Series Oracle. The Flare Time Series Oracle is a way to come to consensus over data from multiple sources. Um, so
Mm.
the Flare Time Series Oracle is built to get prices, indice data, carbon emissions data, um, essentially anything that fluctuates over time, and that's run by
Mm.
what we call um, Flare Time Series oracles, and uh, we have currently more than 100 of those oracles.
Mm.
Although we're capped at 100 for now, but there's actually a list of people trying to get into the system.
Mhm.
The system is expected to be expanded, beyond 100 over the next sort of some period of time, and that makes it an incredibly decentralized price oracle. So there's 100
Mm.
oracles for each price. There's 100 entities giving you each price. That is far more decentralized than any other system. The reason we can do that is because it's fundamental to the network. It's core to the network. It's built into the network. If you were trying to build that on top of another layer one, you would simply run into gas constraints that made it completely infeasible. And
Mm.
that's why we had to start a blockchain in order to make this work. So, the other solutions are pretty centralized. Um, we've managed to create a truly decentralized solution, um, because it's secured itself and it is part of the blockchain. And ultimately, the Flare Time Series Oracle nodes will become the validators of the network. So it's the first
Mm.
solution, and it's a fantastic price oracle. The
Mm.
second is the state connector. The state connector again uses the network structure to create a mechanism by which deterministic data can be essentially come to consensus to by the network nodes. And this is incredibly important. Um, so
Mm.
that applies to things like blockchain state data, so what we call deterministic and immutable, and then things like what we, I guess, loosely term quasi-deterministic data. So this is an API from the internet that acts as a single source of truth. That single source
Mhm.
of truth might be something like Twitter, might be something like Facebook, might be something like a game, essentially where if all participants go to that API, they get the same answer out. It's only quasi-deterministic because obviously someone's managing that database and can change the answer if they wish. Um, so that's,
Mm.
but essentially the state connector allows you to get both types of data. Um, Blockchain state data has a stronger security guarantee than API data because
Mm.
really our great innovation for the state connector is that there's a binary forking protocol for blockchain state data, which means that essentially no majority of the nodes can essentially overrule the minority. And this is, I won't dig into it too much, but the binary forking protocol is what allows Flare to be somewhat invariant to the value of a transaction happening. And this is incredibly
Mm.
important.
I see. Awesome. I've got a question on the time series oracle. Like, how do
Sure.
you guys distill all the aggregated signals that you're receiving from all the validators? Is it like you get the average time that all of them post, for instance?
So it's what's really nice is that anyone can reassemble the signal however they like. So all the data is exposed on chain
Okay.
from each oracle. So you can process that data however you like. We process it one way, which is to chop off 25 and 25 of the distribution, about the 25%
Mm.
above the middle and the 25% below the middle. Then we take a median, which is weighted by the amount of delegation to each oracle.
I see. I see. So that's like a kind of like security mechanism to get like the most accurate price feeds.
Well, taking out the 25 and 25 takes out outliers and it takes out
Mm.
attempts to skew the system. And that leaves you with essentially what you're looking for, which is generally called a Schelling point.
Mm-hmm. Awesome. Good stuff. Good stuff. Now, you mentioned that state connectors have kind of like a independent attestation mechanism. I've also read that in your documentation.
Yeah,
So I was wondering, could you explain a bit more about the role of like the attestation providers? How do you
yeah,
become one?
absolutely,
Yeah,
absolutely.
and stuff.
So there's two roles of attestation providers. So what an attestation provider is doing is someone, let's say me, asks a question on the blockchain. I'd say like basically, please help me prove that this transaction happened on Ethereum. In this block, it was for this amount of value. It was between these two addresses, that kind of thing. And I
Mm.
specify this in a data structure that we call an event,
Mm.
and I submit that from the client side software.
Mhm.
Um, Essentially, then there's two sets of attesters. And I might be an attester, but there's let me give you the sort of general layout of the attesters. So we have what's known as default attesters. So
Mhm.
these are the main attesters in the system. They are essentially the majority of them are composed of the validators. So
Mm.
ultimately, the FTSO role will become an attestation role. So essentially, the
Mm.
FTSO, the attester, and the validator is one role on Flare. And so that means we have a very large number of default attesters. Um, and then essentially that default set comes to consensus. Yes or no, the thing you requested is true or not true. Um,
Mm.
Now that's essentially, if you want to think of that, that's basically a proof of stake system based on essentially the admittance of those validators to the default set. Proof of stake is fine for many aspects, but it is problematic when it comes to large amounts of value, because as you
Mm.
know, proof of stake only works. Essentially, you have two guarantees in proof of stake. You can have a third of the value. Essentially, if you have a third of the validators, come offline, you lose liveness,
Mm.
and obviously consensus happens at two-thirds of the validators. So, if there's a sufficiently large transaction, it may make sense for the validators uh, to essentially lie about it if
Mm.
there's some advantage to that. some financial advantage to that. And we see this actually happening in existing proof of stake systems, whereby some of those systems, cross-chain systems, are securing a greater amount of TVL, so value bridged across chain, than the amount of stake that they have
Right.
at risk. And this, to me, is a very dangerous place to be. And my suspicion is the only reason that they are broadly not getting attacked is that many of those entities are being secured by their teams and their associated VC funds. That's not a situation that's decentralized nor can persist for forever. So we wanted to think about how we could create a system which was invariant to that kind of problem. And this is where the second attestation type comes in. So we call this a local attester. Now, a local attester runs a node, and a local attester essentially is responsible for its own security. So a local attester might be attached to something like an application that cares about what is happening on Ethereum. An application that cares about what is happening on Bitcoin, an application that cares about, some aspect of the data. And that attester also puts all of the attestation types into the network itself. So it goes and gets that data itself, it checks it itself. And most importantly, when the default set and the local attester do not agree, the local attester stops making progress on the network and essentially halts and is safe. Most importantly, all attesters that do not agree with the default set stop and halt. They stop and halt with the same state, meaning that their local database is identical on what has happened on Flare. So this gives you the ability, in the rare case that the default set is malicious, gives you the ability to restart the network incredibly quickly without essentially the malicious data being part of the network state.
Right, but would it halt the network though if there's a conflict in their attestation?
So if there's a conflict, if the default set always have to agree. They can't not agree. So they either say yes or no. Depending on how that answer happens, the main network will always continue. But the concept behind the local attesters is that essentially the main network is not continuing for those that don't believe the result of the default set. Now, 99 times out of 100, those local attesters will be incorrect. They'll go and recheck their data, and then they'll just join their node to the existing to the network that is run by the default set. But in that very, very rare time, if the default set is essentially malicious, then essentially what you have is, rather than having to stop the network, roll it back, somehow kick out a malicious set, you have a network there that doesn't have contaminated state, but B, what people need to understand about the local attester role is that it's a proactive security module. So essentially every participant that cares about what's happening on the network, if they run a local attester, then it's impossible for them to make a response on another chain or act on data, act on anything they're seeing from Flare, based on essentially faulty data from the default set. So they're securing their own view of the world relative to the default set. And this is sometimes a hard concept for people to grasp if they don't understand fully how and why blockchains do things. But you've got to understand blockchains are only a mechanism to come to consensus across multiple participants, and each participant should have their own view of the data.
Got it. Okay, so for those of you who have just joined us, we are talking about the role of attestation providers in the Flare network setup, and on a high level, and correct me if I'm wrong, Hugo, here, the role of attestation providers, is to ensure that the external data that goes into Flare network is correct and that the network itself has consensus on the external data. Am I right?
Yeah, that's absolutely true. And for those operating a local attester to proactively secure their operations, in the
Got it.
same way that you run a node if you want to have high performance on a network and actually
Yep.
understand the data that you're seeing,
Awesome.
not
So now,
relying on a third party.
got it. Who can be local attesters? Can anyone be
Anyone
that?
can run a local attester, yeah.
Oh, I see. Cool. That's really cool.
Most importantly is local attesters all fork to the same. Essentially, if they fork against the default set, meaning they do not concur with the data that the default set has agreed, they all fork to the same place rather than each to their own place.
Awesome. Which brings us to the point that I think you briefly mentioned just now, which is that it seems like the state connector mechanism differs quite a bit from third-party Oracle services. Could you break it down for us a bit more here?
I mean, yes. So again, the state connector is built as a part of the network, versus a third-party Oracle service that could only ever be on top of a network. And that gives you just totally different security guarantees. It also gives you different liveness guarantees because you can have more nodes. So that you'd be limited. Generally, you'd be limited on the number of entities you could have with a third-party Oracle because ultimately you'll run into some kind of gas constraints. Whereas we don't have that issue because it's operating outside of the EVM and outside of the VM. And so it means that we can make it far more decentralized. It's part of the network. It doesn't run into constraints. Basically, it's a substantially better design than building this kind of thing on top of a chain.
I see. This is really interesting. I learned a lot of new things about the Flare network. And the gist of it that I learned so far is that it tries to solve a couple of pesky problems that chains like Ethereum and the EVM chains have, right? Which is the problem of getting data into the network and ensuring that it is a decentralized service. So for Flare, it builds all these mechanisms into the network itself. Amazing.
Exactly. I think that's a perfect summation.
Yeah. So right now, I believe Covalent has indexed 3 series of your network. You've got a mainnet, you've got a testnet, as well as Songbird network.
Yeah.
I'm curious about Songbird. Could you tell us more about this network? Is it an app chain?
So Songbird is built to be essentially the canary net for Flare. So it is a layer 1 EVM based chain with Flare's data protocols built into it. The risk you have when you get to things like look, we've all seen these bridging issues where even bridges that are funded by one of the largest hedge funds in the world or trading funds in the world have had major issues. The reason for Songbird's existence is that interoperability is hard. You're dealing with multiple systems across different zones of sovereignty, meaning that each chain has its own type of consensus protocol. Building interoperability is a bit like building a Swiss watch, right? You've got to have these cogs that click across, make the next click based on something from somewhere else, another cog. So to give you, an example, you want to have interoperability between Cosmos and Ethereum. You've got to wait for Ethereum to come to consensus. You've got to wait for that cog to click along. You've got to be certain that that is correct and you're not on a fork, and all those kind of things. So you've got all these, many layers. It's very, interoperability is a very much more complex thing than building a dApp on a chain.
For sure.
And so Flare brings you this data, but we really want developers who build interoperability applications to put them on Songbird first, test them, and because Songbird's essentially Flare but with a health warning.
Okay.
Yeah, the idea is it says to the user, have a go. You may lose all of your money. This application might be ruined. It might have a bug. It might have this. It might have that. There's so much that when it comes to complex systems, there's a lot that cannot be accounted for in the internal testing and the bug, catching bugs. And many developers who have been working on Songbird have found bugs in their code, and that's the use case for it.
Got
It's
it.
also separately, it is the first stage of governance in Flare. So for community governance proposals, those must be voted on Songbird first. So essentially, what we didn't want to have with Flare was to have an endless number of governance proposals that no one cares about. So on Songbird, we have governance rounds once a quarter. We will have, once Flare is out of beta, we'll have governance rounds once a quarter. People will stake to essentially each governance question, and the governance question that accumulates the most stake is then passed up to Flare to be ratified. So it's got this bicameral governance system. Songbird, of course, then has its own governance where it can change its raison d'etre, so it can completely divorce itself from Flare if it wants to and become its own L1. Or it can change its parameters in certain ways or whatever. That's one role of Songbird. But then lastly, Songbird, with interoperability between Songbird and Flare, it can become an overflow compute network.
Wow, that's really interesting. There's a lot of directions of data flow here. And what's interesting is how Covalent comes into the picture, right? And for those of you who are listening, we are also celebrating that we have recently indexed Flare network across 3 of their networks. That means that you can now access Flare on-chain data, right, through the Covalent's REST API service. So that's a more classic way of getting data, like Hugo mentioned. But what's interesting about how you can get data from Covalent through Flare this time is that Flare itself has mechanisms of getting like external data, right? Data from everywhere on the internet through, of course, attested through their attestation provider mechanism. And then after that, it is brought on-chain. And then Covalent will then take that on-chain data for it to be available through your dApps. So there's a bit of a, like a crisscross thing going on here. So I find that pretty interesting.
Yeah, exactly. As I said at the start, I think, us and Covalent are very similar. You do it for off-chain, we do it for on-chain.
Yeah, precisely. So for those of you who are listening, and if you're developers, you can now go to the Covalent API reference and be able to directly access Flare networks on-chain data as well through our mostly through our Class A endpoints here. So yeah, that will make building dApps really simple, especially if you need to integrate front-end analytics portions into your dApp, right? But if you want to build on Flare's backend or the blockchain layer, how can developers start building on Flare?
So the nice thing is it's EVM based. There are more performant virtual machines, as we all know, but everyone knows EVM, and it's
Yep.
you need to achieving a network of scale is as important as having an important a good virtual machine. Um, so EVM is where we are for now. That can be switched out at a later date, if that's desirable. If the community says that's desirable, let's say some alternative VM comes along and it's incredibly popular.
Mhm.
So it's EVM based, so that makes it easy. Then of course, just going to our website, there's docs and tutorials. It's flare.network, and you can follow the links.
Awesome. Excited. That means that you can basically use all your EVM compatible development suite while you're building out your dApp on Flare, right?
Exactly.
Okay. One final question before we wrap up today's awesome AMA. Tell us more about the Flare improvement proposal that has just been approved by the community.
Yeah, so it's one of the mechanisms of governance. It's called a Flare improvement proposal. Ultimately, that will become something that can be created by the community after Flare exits beta. I think the one you're referring to is FIP01, which allowed the token to essentially change the way the token is distributed. So initially, the token was distributed. There's a large amount of tokens that are being distributed to the public. I think about I can't remember the exact number off the top of my head, but those were initially distributed to a single set of participants over the first 36 months of the life of the chain. Now, those tokens are essentially what the FIP01 did is it distributed 15% of those tokens to that set of participants at day one. And then it basically, the other 85% will now be distributed to anyone that wraps the token on Flare. So it sort of decouples it from the original snapshot and essentially rewards those who obtain the token and wrap it. So essentially, is the concept behind that is it encourages participation, it encourages the community, it encourages the community to diversify. A snapshot will often capture people that have no interest in the project, and this allows essentially for that person that has no interest in the project to be swapped out for someone that does have an interest in the project.
Awesome. And through this mechanism, everyone can now be active participants in the Flare ecosystem, am I right?
Absolutely. It also puts those who come to the project now on an equal footing with those that come to the project, came to the project earlier. And that's incredibly important because, adoption is key.
100%. So those of you who are listening, that's some alpha for you. Go learn more about Flare, participate in the network, and you'll be surprised. So one final question for our more broadly EVM developer audience base. If you have, let's say, 10 seconds to pitch to them to start building on Flare network, how would you pitch it to them?
I pitch it very simply. Build applications with data from other blockchains, from Web 2, and with great price data. And don't just serve our network. So don't just build an application that serves our network. Build an application that can serve all networks through Flare. So that's kind of the idea. So to give you an example, we did a demo the other day on Songbird, where you can buy an NFT on Songbird. So the token exists on the Songbird network. You can buy that NFT with multiple currencies. And in this demo, it was purchased with Doge and it was purchased with XRP. But it could also be purchased with Bitcoin, Ethereum, Litecoin, any Cosmos coin, anything that the state connector can attest to. And the flow was a transaction was made on, say, the Dogecoin network. That transaction was attested to Flare. That released an NFT on Flare. So this ability to do this means that NFTs can be priced in multiple currencies simultaneously through the FTSO. So that means a marketplace is no longer restricted to one currency, but it also means that an artist can issue NFTs that have the maximum possible reach. So they don't only need to pitch the Ethereum community, they can also pitch all other communities at the same time. So it's instead of being a niche, tiny gallery on a back street, they can be, right on the main street.
Right. So, wow, this is a really interesting example. And I know we're running towards the end of this, but I just want to ask a bit more because I'm really curious. You mentioned that the purchase of the NFT was done on Flare network itself, right? And
on Songbird, the Canary Net.
On Songbird itself,
Yeah.
right? And what happened there was, wait, is Doge on Ethereum? It's on Ethereum, right?
No, Doge is its own
its own network.
chain. Yeah.
Okay, its own network. Okay. So a transaction was sent on the Doge network, which probably transferred that NFT to an address, right?
No, let me. The exact flow was: you come onto Songbird, you reserve the NFT with a small payment. Let's say that small payment in the secondary market. Let's say that small payment is the commission, essentially the ongoing trailing commission. So the royalty. So that small payment can go to the artist. So that goes into a smart contract. It can go to the artist who originally issued the NFT. Cool. So we've reserved our NFT. Now we go pay the seller. Might be the artist if it's a primary mint, or it might be the owner if it's a secondary sale. Now I go pay the seller on whatever network they have specified, or they may have multiple addresses. So if I'm a seller, I might have an address on 20 chains in order to get paid. And so I get paid on say the Doge network. So now I've paid the seller on the Doge network, and the state connector is used to attest that payment to Flare to trigger the release of the artwork to the buyer.
I see. And on the side of the primary network, is there like a transfer of the asset there?
On a network, no. It's the asset exists on Flare or on Songbird. It doesn't exist on the network where the NFT was purchased. The reason being is that many networks don't have NFTs. Ultimately, with a relay network, it is possible to create the transfer on any network.
Got it. I see. That's really cool stuff. And this feature will presumably be like live soon, right?
Well, that feature is available today on Songbird. It's really
Amazing.
up to marketplaces to integrate it.
Amazing. So devs, go check this amazing feature out. And with that, I think we've kind of reached the time limit for today's AMA. Thank you so much, Hugo, for joining us.
Thank you so much for your time.
Yeah, and thank you everyone for listening in. And as always, just, dive into the docs, dive into the website, explore it yourself, be an active member of the community, and hope you learn as much as possible. Thank you, guys.
Thanks a lot. Have a great evening.
Take care. Bye.
Thanks. Bye.
Mission Control, we have liftoff.